Hi everyone, this is practice summative of chapter 4, paper 1, question number 4. So during the school year-end dinner, every round table must be seated with 10 people. The VIP table has only 6 seats. 6 teachers are selected from 5 maths teachers and 5 science teachers to fill in the vacant seats at the VIP table. So we need to find the number of ways to seat the teachers if there are no conditions imposed. But before that, we know that we have to select 6 teachers out from the 5 maths teacher and 5 science teacher. Okay, we've got to choose 6 teachers. When there are no condition imposed, therefore, let's choose 6 teachers. So that will be 10C6. And next action is to permute them around the table. So we will have 6 minus 1 factorial. Okay, so with the help of calculator, we take 10C6 followed by 5 factorial. 5 factorial. So there are 25,200 ways to seat the teachers. 25,200 ways. Okay, next, let's move on to part B. Now, part B, mathematics teachers cannot sit next to each other. So, to find the number of ways to seat the teachers in such a way that maths teacher cannot sit next to each other, it depends on who are the teachers that are selected in the first place. So we may have selected all 5 science teachers. So when we have 5 science teachers, we just need to choose 1 maths teacher and then we sit them around the table. Or the second scenario is when we only selected 4 science teachers, therefore the remaining must be the maths teacher, or 3 science teachers followed by 3 maths teachers. We cannot have 4 maths teachers because the moment we have 4 maths teachers, if we sit them around the table, see maths teacher, 4 of them, we left with only 2 science teachers. So 2 science teachers can sit any of the 4 vacant place between the maths teacher. When 2 is taken up, we still have these 3 maths teachers that will sit next to each other. So we will never have 4 maths teachers in the arrangement if we don't want them to sit together. So we only have this 3 scenario here. Okay. Now let's look at the first scenario. Okay, let me use the illustration. So let's put in the 5 science teachers. So we have 1, 2, 3, 4, 5. The first science teacher just take any seat, and then the remaining 4 teachers will just take the place. So we will have 4, 3, 2, 1. And the remaining of the empty space in between the science teacher will be the choice for the maths teacher. So we have 5, okay, P1 for that maths teacher. But before we do this, we have to select out of 5 maths teacher, we choose 1 maths teacher to be permuted together with the science teacher. So we multiply for the science teacher, 5 minus 1 factorial, which is 4 factorial, and followed by the spaces in between the science teacher. We have 5 spaces. Choose any one of the 6 to place our maths teacher. This is one of the way. Or we can also take 5 maths teacher, we choose 1, and then the 1 maths teacher join with the 5 science teacher. So we have 6 of them. So 6 minus 1 factorial. 6 minus 1 factorial. Because there is only 1 maths teacher. Maths teacher will never sit with another maths teacher. So we just put them in the together with the 5 science teacher to permute around the table. So both will give us the same answer. I can prove it to you that let's put 5C1 times with 4 factorial and then times with 5 empty spaces between the science teacher, and then one of them is used to seat the maths teacher. So 600 ways. Okay, so over here we have 600 ways. All right, or alternatively, let's check if I were to use the second method, 5C1. And then we put the maths teacher and the science teacher together. All right, that will be 6 minus 1 factorial. That means 5 factorial. See if we can get the same answer. Yes, we get the same answer, 600. So choose either one. All right, or means we plus. Okay, we got a plus. Now let me just illustrate the diagram. So let's sit the science teacher. The first science teacher that goes in, all right, has only one way to sit around the table. Okay, the remaining 3 science teacher will go by 3, 2, 1. Okay, the space in between the science teacher, we have 4 spaces. So choose any of the 2. Okay, we permute the 4 vacant seat among the 2 maths teacher. Therefore, we will have first, out of 5 science teacher, we choose 4. And followed by out of the 5 maths teacher, we choose only 2. We choose the teachers first, then only the next action is to permute them around the round table. So in this case, we will do the science teacher first. That will be 4 minus 1 factorial, or just based on the diagram, 3 factorial here, 3 factorial here, and then followed by, we have 1, 2, 3, 4 empty spaces. So 4P2. Okay, that will be, let's check the answer. 5C4, 5C4 times with 5. We choose any of the 2 maths teacher. Okay, we choose any of the maths teacher. And then followed by 3 factorial or 4 minus 1 factorial to permute the 4 science teacher, and then followed by 4 empty spaces in between for us to seat our 2 maths teacher. So 4P2. Okay, so 3,600 ways, 3,600 ways. So the last one, all right? We have 1, 2, 3 science teacher. Okay, therefore, in between them will be the maths teacher. So over here, maths, maths, maths. So they will never sit together. So for this kind of arrangement, first we have to choose 3 science teacher out of 5 science teachers, followed by choose 3 maths teacher out of 5 maths teacher, and then we put in the science teacher first. That will be 3 minus 1 factorial. Okay, why is it 3 minus 1? Because we put the first science teacher in. There is only one way for him to sit. And then the remaining 2 science teacher will take up the space. So 2, 1. So that is why we get 3 minus 1 factorial, which is 2 factorial. Let me just write like this, 3 minus 1 factorial. That is for the science teacher, followed by the maths teacher. We shall take up the space in between the science teacher. So there are 3 spaces between the science teacher. Therefore, 3, we fill in all 3 maths teacher. That will be 3 factorial. Okay, so with that, let's use the calculator. So 5C3, okay, overwrite it. 5C3 followed by 5C3, then followed by, to arrange the science teacher, 3 minus 1 factorial, so 2 factorial, and then followed by, okay, this is, all right, we can use either 3 factorial or 3P3. They mean the same thing. So we have 1,200 ways. So 1,200 ways. Okay, don't forget, or means we got to plus them. Let's add all this together. Okay, therefore 600 plus 3,600 plus 1,200. Okay, this is the alternative. We can just erase now. Okay, equivalent to 4,200 plus 1,200, we have 5,400 ways to arrange the seat so that the maths teacher cannot sit next to each other. That's it for question number 4.